All right, today we're in section 9.5, the distance and midpoint formulas. Good news with formulas is once you learn the formula, it's just a matter of plugging in the numbers in the right spot. So it's not going to be overly complicated to solve them. The hardest part is going to be remembering the formula. All right, the first formula you need to know is the distance formula. The distance formula, in so many words, is basically the distance between 2 points on the coordinate plane. Now, we know that points are plotted on the coordinate plane using ordered pairs. Okay, so ordered pairs, that's going to be a big part of what we're learning in today's lesson, ordered pairs. All right, so go ahead and write down the distance formula that I have circled right here on the slide. All right, so your original problem on every homework problem tonight that calls for finding the distance, it's going to be that formula, okay? So you don't have to copy what's in the book. You're going to use the formula. In the classwork today, I'm not going to make you write the formula over and over and over again. Just remember, though, in your homework tonight, I want that to be the first thing you write for every homework question. That is your original problem. You lose points if you don't write that. All right, so let's just start off with the substitutions here on the classwork. So it says find the distance between the 2 points. Well, here's the good news. The good news is we number or we categorize our x1 and x2 values the same way that we did with slope. So the very first x value, that's going to be my x1 and my y1 and my x2 and my y2. And it's like that every single time, okay? So that's how I'm going to figure out which one's my x1 and x2 value, which one's my y1 and my y2. All right, you guys remember that? So in the order that we read the ordered pairs, that's how it goes. So with that being said, now I'm going to plug in these values into my distance formula. Distance formula is the square root of, what is it? x2. So which one is my x2 value? It's going to be 5. Minus x1. Which one's my x1 value? 6. And then square it. Plus y2 minus y1 squared. Do you see how I plugged in the numbers? Are you doing it on your papers? All right, and now I'm just going to follow order of operation. So I need to simplify what's inside the parentheses first. What's 5 minus 6? Negative 1. Now here's where it gets real sensitive, okay, especially if you're using your calculator. Leave negative 1 in parentheses when you raise it to the power of 2. Because negative 1 squared, what's that saying? It's saying negative 1 times negative 1. So what's negative 1 squared?
Negative 1.
Positive 1. Because that's negative 1 times negative 1. That's 2 negatives being multiplied together. Make sense? Now, if you put it in your calculator, negative 1 has to be in parentheses for the calculator to tell you the correct answer. All right, so we get the square root of 1 plus, what's 7 minus 3? 4. What's 4 squared? 16. 1 plus 16 is the square root of 17. Can I simplify that anymore? Can I pull out any perfect square factors? Nope, so that's my answer. Square root of 17. Okay. Now I want you to go ahead and try to set up the second one, all right? At least try to get your substitutions. If you feel like you can solve it, go ahead and solve it. Hayden, what did you get when you substituted?
Negative 2 minus 4 squared plus 3 minus 1 squared.
Very good, perfect. Now, what is negative 2 minus 4?
Negative 6.
Negative 6. So again, be careful. What is negative 6 squared?
36.
Positive 36. Again, if you put it in your calculator, make sure negative 6 is in parentheses. All right, so I get 36 plus 4 is the square root of 40. But is that my final answer? No, because I can pull out a perfect square factor. And what would be my final answer? You can just take the square root in your calculator. 2 to the square root of 10. Because you can, 4 times 10 is 40. You can take the square root. Okay, so that's where your calculator will come in handy. Go ahead and try number 3. Try number 3. Find the distance between points P and Q. Okay, so square root, make my substitutions. Oh, wait. What is that? So I've got -4 minus, and I had to plug in a -1. The minus is already in the formula. Then I plug in a -1. What does that give me? A double negative. Anybody catch it? I bet you'll catch it next time. Okay? Plus 1 minus 5 squared. And then when I evaluate, I get actually an even 5. Sorry about that. I get 5. Just get 5. Anybody get 5?
I did catch that, yeah.
Okay, the double negative. Good job, guys. All right, so the double negative you're going to see often. So just make sure you catch those and you change them to positive before you evaluate. All right, now in the next example, it gives me basically the coordinate plane. And it says that each one of these points marks a spot on the ground where a bird ate. Okay, I don't know why. They're just bird watching, and they marked the points on the grid where the birds were feeding. So here's what it wants to know. It wants to know what is the distance between bird A and bird B. Well, in order to find the distance, I have to have an ordered pair. The word problem doesn't give me an ordered pair. Or does it? Can I pull an ordered pair off the grid? Can I find its location or its coordinates? So let's look at bird A. Can anybody raise their hand and tell me what would be the ordered pair for bird A? Colin?
3, 2.
It would be 3, 2. Do you agree? Over 3, up 2. So bird A, the ordered pair is 3, 2. All right, now I want you to try to find bird B. Find the ordered pair. Okay, so bird B, Kenneth, what's the ordered pair?
7, 5.
7, 5. Very good. All right, so on your homework tonight, they're going to maybe give you a couple of these grids, and you have to figure out the ordered pair. Now, ironically, this is actually the exact same set as the one that we just solved, but basically, once you have the ordered pairs, you just make your substitutions like you did, okay? 7 minus 3 is 4. 4 squared is 16. 5 minus 2 is 3. 3 squared is 9. And you get 5. You just solve it just like the other ones, okay? So the only thing that we did different in example 2 was we actually had to figure out the ordered pair from the grid. Does that make sense? Yes? No? Okay. All right, so that's it for the distance formula. Now you need to know the midpoint formula. Go ahead and write this down in your notes, the midpoint formula. The midpoint is the middle distance between 2 points on the coordinate plane. So, like we just found for bird A and bird B, we found the distance. This is basically helping us find exactly halfway between those 2 points. That's what the midpoint is. Okay, so now guess what? It's going to look pretty similar. Find the midpoint now. So now I have 2 sets of ordered pairs. Now I'm going to use a different formula to find the midpoint. Same thing though, it's going to be my x1, y1, x2, y2. My numbers are still categorized the same, x2 and y2. Does that make sense? So my numbers are still categorized the same. All right, so now I have my parentheses. Oh. Sorry. Okay, so m equals x1, which is 3, plus -9, because that's x2, over 2, comma, y1 plus y2 divided by 2. All right, and now I'm just going to simplify. What's 3 plus -9? -6. Over 2, and what's 8 minus 4? 4 over 2. Now with the midpoints, if I can simplify them, it's just like slope. If I can simplify it, then I need to simplify. Don't change it to a mixed number though. Just simplify. Leave it in an improper fraction if that's what it is. Can I simplify -6 over 2?
Yes.
No. Yeah.
-3. Can I simplify 4 over 2? 2. That's my answer. That's the midpoint between those 2 points. Okay? All right, I want you to try the second one. Okay, so m equals 7 plus negative 3 over 2 and 5 plus 1 over 2. So negative 4 or 4 over 2 and 6 over 2. Can I simplify that?
Yes.
2, 3. Who got 2, 3? Did y'all get 2, 3? Good. All right, go ahead and finish the last one now. Okay, so did the 0 throw you off?
No,
No, it shouldn't, because 0 over 2 is just going to be 0. Negative 1/2 and 0. Negative 1/2 and 0. 0 divided by 2 is 0.
Man, I am such a
Oh, see, there you go. You got to be more confident. All right, very good. All right, negative 1/2 and 0 is the answer. Last formula. Hopefully you already know this one. Your slope formula. Y2 minus Y1 over X2 minus X1. If you don't remember it, write it down in your notes because you need to know it. Okay, so to find the slope between two lines, unless it's a vertical line, there is a slope, or the degree at which the line is slanted. Rise over run will give us the slope. All right, y2 minus y1 over x2 minus x1. Look familiar? Two sets of ordered pairs. But now we're finding the slope. So you use ordered pairs to find distance, midpoint, and slope. So again, it's still my x1, y1, x2, y2. But now I'm just plugging it into a different formula. y2, which is negative 3, minus y1 over x2 minus x1. What's negative 3 minus 7?
That will be negative 10.
Negative 10. And what's 8 minus 3?
5.
Can I simplify?
Yes.
Negative 2. That's my slope. All right, I want you to go ahead and try the second and the third one. Use your slope formula to solve. Okay, so hopefully you're at least done with the second one. So we have 9 minus 4, did you get that?
Yes.
Over 7 minus 2. So 5 over 5 is 1. All right, third one, there's one little tricky part. Let's make sure everybody catches that. I'll give you just a couple minutes and we'll finish it up. All right, so double negative. 4 minus negative 1, so it's going to be 4 over 5. Who got 4/5? Awesome. Good job, guys. If you understand that, that's everything you need to know for 9.5.